Okay, geometry, 5-2 medians and altitudes of triangles. In the last section, we did the circumcenter. Today, we're going to concentrate on the centroid and the orthocenter. So we're going to start with the centroid. Okay, and the centroid, what we're going to actually do is find the median of each side, and then we're going to, we're going to find the median of each side, and kind of a little different than the circumcenter that we did in the last section is these don't have to be drawn perpendicular. So I would find the median of each side, and I'm going to connect it with the opposite angle or the opposite vertex. So for example, let's say, and these will be drawn for you. Let's say this is, am I on a pin? This is my median. I'm going to draw from the angle that's opposite. Ooh, I don't like that drawing. I don't like that one either. Let me get a good one. Okay, for the sake of time, I went ahead and drew in those medians. Again, the median is from the opposite angle, and so I can color code this. That median to that angle, that median to that angle, let's go with the purple, and that median to that angle. Okay, and their intersection in the middle is called a centroid. So now I'm going to label these. I'm going to call this triangle ABC. And then I'm going to label the medians D, E, and F. And then I'm going to label in the middle the centroid of G. Okay, now the centroid does have its own theorem. Okay, and that theorem is, if I look at AE as a segment, okay, AG, which is the distance from the vertex to the centroid, is 2/3 of the entire segment. Okay, so from the vertex to the centroid is 2/3 of the entire segment. And so CG is 2/3 of CD. And then I've got one more to go. I've got BG, and that is going to be 2/3 of BF. Okay? So the distance from the vertex to the centroid is 2/3 of the entire segment. So where might we use this? Well, let's say I have our given triangle. Okay, so let's say that AE is 9. And I want you to find AG and GE. Okay, so I'm going to use my centroid theorem, and I'm going to start out with my first one, which is AG is 2/3 of AE. And since I know that AE is 9 in this case, I have AG equals 2/3 times 9/1. Cancel the 3 into the 9 3 times. So AG equals 3 times 2, which is 6. And I know if the whole segment is 9, then GE has to be 3. Okay, and that's centroid, again, if it's drawn from the median. Okay, so now we're going to talk about an orthocenter. Okay, The orthocenter has to do with the altitudes. So we're going to draw in the altitudes of these. And you know what? I don't like that triangle because I keep using the same one. So let's make it look a little bit different. Let's make it look like that. Okay, so I'm going to draw in the altitudes of these. And remember, altitudes are drawn perpendicularly, so we need to create 90-degree angles. See if I can get a couple of these real quick so I don't have to. Again, these will be drawn for you. So there's a pretty good 90-degree angle right there. And then obviously this one will be straight down, would be 90 degrees. And then this one, because I've already drawn it, I know it's going to be, if I could get a good one, okay, so this is 90 degrees, this is 90 degrees, and this is 90 degrees. And that point right there is called the orthocenter. Could have drawn a little bigger triangle, but that's all right. Okay, so the orthocenter is drawn when the three altitudes meet in the middle. Now on these, there's no equality of segments. There's no 2/3 of a segment like there was just a little bit ago on the centroid. For these, they might actually give you coordinates and have you find the orthocenter, so you'd actually graph it. So you would have to find the perpendicular lines using the slope formula, and then you would find your orthocenter through the connection of those. So that's just about 7.5 minutes. That is 5-2, medians and altitudes.